So here's your packet lesson. Starts on page 41, but this is your packet lesson 2-3, problem solving using inequalities. Now I'm going to save this one for a little later because it's like a tongue twister as far as story problems go. I don't want to intimidate you to get started. I want to start with something a little more concrete, a little more basic. So let's start with example 2. It says the length of a rectangle. Remember what I taught you guys in class last time we met? Every picture tells a story, don't it? So, don't do these problems without giving your brain a chance to look at what's happening in the picture. So it says the length of the rectangle is 5 inches more than 3 times the width. So, see how this comes last? I'm going to call that x, and I know that's my width. And then it says the length, see how they're comparing it to the width, is 5 inches more than 3 times the width. So I'm going to go 3 times the width and then add 5 because it's 5 more than that. And if that's 3x plus 5, that has to be 3x plus 5. So there's the geometry part with a little bit of algebra. And now here comes an inequality. It says find the smallest possible width. Keep that in mind. Here comes the meat and taters. If the perimeter, what is that? That means add this to this to this to this. Let's stop right there. X plus 3x is 4x, plus x is 5x, plus 3x is 8x. And I add these constants and I get 8x plus 10. See, it says the perimeter is at least 90 inches. So if I drew a little picture and I know there's a 90 there, if it's at least 90, it can include 90 and be something bigger than 90. So we're going to take a look at that. We're going to say this perimeter is greater than or equal to 90. And now it's just like a basic math problem. Subtract 10 from both sides. So I get 8x is greater than or equal to 80. Divide by 8, divide by 8. I get x is greater than or equal to 10. And now let's go back to the question. Very important you go back to the question with this stuff. It says find the smallest possible width. Notice we assign the value x to the width. And this says the width, x, can be greater than or equal to 10. But this says find the smallest possible width. Well, it's 10. Because on a number line, if it can be 10 or bigger, and it's asking me what's the smallest, it can be 10. All right, so let's warm you up with example 3 before we go back up to example 1. It says the lengths of the sides of an isosceles triangle. Now you got to know what that even means from geometry. It means that 2 sides are the same. Now this is a leg, this is a leg, and this is considered the base, just so you know. And it says the lengths of the sides of an isosceles triangle are integers. The base is a fourth as long as each leg. So what we're going to do is we're going to think of it slightly differently. We're going to take the base and we're going to call the base x. And then it does say the lengths of the sides of the isosceles are integers, and the base is a fourth as long as each leg. Well, if we think of that in reverse, if the base is 1/4, see this is smaller than a leg, then we're going to say, hey, we're going to let each leg be 4x. We're going to let each leg be 4x. And then it says, what are the possible lengths of the legs if the perimeter is between 10 and 30? Well, again, the perimeter, well, that'd be 4x plus 4x plus x. So 4x plus 4x plus x is 9x. See, this is the perimeter, is between 10 and 30. That means greater than 10, less than 30. Now watch. This portion says this. Remember from our previous lesson, if I have something written like this, it always implies the word and. So, and 9x is less than 30. Now, if I solve this one, I'm going to divide by 9, and I'm going to flip this, so be careful. It says x is greater than, see, if I'm reading from here to that stuff, it's x is greater than, and then 10/9. And now if I divide by 9, I'm going to get x is less than 30/9. I'm going to show you guys something using my calculator. Turn it on, clear this. I'm going to go 10 divided by 9 is 1.11. So x is greater than 1.11. And x is less than, see, now I'm going to do the other one. I'm going to do 30 divided by 9. And that's 3.33. So, back to this word. It says the lengths of the sides of the isosceles triangle are integers. That means whole numbers. So really we're going to say, okay, what are the whole numbers? If I look at this situation, if I say, okay, this is 1.11 and this is 3.33, what are the whole numbers in between here? Well, for sure there'd be 2, and for sure there'd be 3. Now remember what we're saying. X can be greater than 1.11, less than 3.3, which means this could be 2, but it could also be 3. And look what the question says. What are the possible lengths of the legs? So if x is 2, and we actually doubled 2, we'd get 8, and we'd get 8. But then x could also be 3. So if we multiplied that by 4, it'd be or 12. Or 12. So these are the possible lengths of the legs there. Kind of a tricky one. Let's go up to this one. It says, a toll booth charges you 75 cents each time you go through. So, pay each time. That's scenario number 1, and you'd pay 75 cents every time you go through the toll booth. And then it says, if you purchase a special sticker, so here comes the or, you got to buy a sticker. So if I get a sticker, that sticker is going to cost $6.25. But then the toll is only 25 cents each time you go through, so that'd be plus 0.25 times every time I go through that toll booth. Now, I only know this because I've done 10,000 of these. But this portion right here, at least how many trips through the tunnel are needed before, I'm going to put a little tiny line through it and concentrate on this. When does the sticker cost less, see here's the sticker, than paying for each trip separately? So sometimes you can't read every single word or else it's just going to mess with your brain. This is the key to the whole thing. When does the sticker cost less? So here's the sticker. And I'm going to say, when is that going to be less than? And now, this is just going to do the math for us. I'm going to subtract 0.25 from both sides. And then here we go. I'm going to get 0.5. It's 0.50, which is the same thing as 0.5, but I'll just write it like this. 6.25. So I'm going to divide by 0.5, which is the same thing as 0.50. 0.5. X is greater than, get out my little handy-dandy calculator, 6.25 divided by 0.5, and I get 12.5. Look at X represents the number of trips I need to take through the tunnel, and it needs to be more than 12.5 trips before I start saving money. So on the 13th trip, it's worth it to buy that sticker. All right, a couple more on the back, and we've only got about 5 minutes, so I need to speed this up a little bit. And 4 and 5 are basically the same, so I'm just going to do one of them because we're running out of time. So I'm going to do this one, example 5. Find all the sets of 3 consecutive even integers. All right, so I know that's going to be x, x plus 2, and x plus 4. That's the algebra 2 way of saying like 8, 10, 12, or 22, 24, and 26. Whose sum, what does that mean? It means add. So I'm going to add these together. So I'm going to go, all right, this plus this plus this is 3x. 2 and 4 is 6. Is between 10 and 20. That means greater than 10, less than 20. Now this is an and problem. So I'm going to take this part of it over here, write it like this, and then I'm going to take this portion and write it right here. So it's a hidden 2 problems in 1. Now I'm going to subtract 6. I'm going to get 4 and 3x, divide by 3, divide by 3. I get x is greater than, I know if I put that as a calculator, it's 1 1/3, so it's 1.3. Subtract 6. 3x is less than 14. Divide by 3, divide by 3. X is less than, I see that's 4 2/3, so that's 4.6, repeating. But remember, we're looking for the integers that are between 1.3 and 4.6. So if I looked at this and I said, okay, here's 1.3 and here's 4.6. Where are all the integers in between there? Well, we got 2, we got 3, and we got 4. But look at the language. It says 3 consecutive even integers. So that would throw out the 3. But now notice x is the starter. And we found out that x can be greater than 1.3, less than 4.6, but they need to be even. So one of them is a 2. So if I put the 2 there and then add 2, I'd get 4, add 4, I'd get 6. So 2, 4, 6 is one of the sets. Notice it says find all of them. And if my other one starts with a 4, then I'd have 4, 6, and 8. And if you added these together, 8 and 6 is 14, 14 and 4, it's less than 20. If I add these together, 4 plus 2 is 6, 6 plus 6 is 12. That's also between 10 and 20. That's how you kind of double check it before you say you're done. All right, 2 more minutes. And I'm going to have to skip example 6 because this one's a little bit different. It says Paige's test scores were 85, 95, 97, and 79. What would she have to score on her next test? We're going to call that X. To raise her average, there's the key word. So I'm going to take these 85 plus 95 plus 97 plus 79. There's 4 tests, but her next test, I don't know. But it's asking us to calculate her average, so I have to take these 5 tests, and it says has to be in 93% and above, which means it needs to be greater than or equal to, I think I said 95, I meant 93. And so I got to multiply this by 5, just to cancel those. Multiply that by 5, and that's 450 plus 15, that's 465. And then I'm going to add these up quickly, and yes, I'm racing against the clock. 85 plus 95 plus 97 plus, oh no, 85 plus 95 plus 97 plus 79 equals divided. Okay, so I get 356 plus x equals greater than or equal to 466. Subtract 356, subtract 356. I get x is greater than or equal to 0, 1, 110. She'd have to get 110 or better %.